Hello, welcome to the math portion of our STEAM project this quarter, working on the earthquake building for Raleigh. As you can see here, you've got your STEAM challenge already written out for you. I'm not going to read that again. The math challenge. Your team has to build a model skyscraper using the parameters set for you in science. However, before you can build, you must design a blueprint drawn to scale. Drawn to scale in architecture means that two sets of measurements are in proportion. When architects draw blueprints, they obviously can't draw the structure on paper because the structure is too big. Instead, they scale the structure down small enough to fit on paper. So we're going to be using the ideas we've learned in math with proportions and ratios, and we're going to take the prototype that you're building or you plan to build, and we're going to draw a blueprint first. So yesterday you and your team sketched out images of what you think your earthquake building, your skyscraper, should look like. Well, today you're going to actually get it on paper. Before you can build, this has to be done correctly. So this is what has to happen. For the math portion of the project, you will need to do the following, you and your team. You're going to have to create two blueprints on graph paper that I will give you. One blueprint will be the ground floor of your model skyscraper. This view shows what your skyscraper looks like if we were looking at the first floor. So if you look at this image here, it's a blueprint. It's literally a blueprint on white paper. You're not going to worry about that. You can just use your pencils fine. But you've got the ground floor of the building. If you Google, or if you go to this link here, it will take you to this page, and it will show you in detail like what a ground floor drawing looks like. I don't care. I don't need to see any tables and chairs and stuff like that for your drawing. But if you have any walls in your building, I need to see that. If you have any doors or windows, I need to see that. And that's what's represented here. We have doors here and we have windows here. So if you plan to have any of that, it needs to be included on your blueprint. So again, this is looking down into your building on the first floor. So that's what your first blueprint has to look like. When you're drawing these, your lines need to be used. You need to use a ruler for your lines. They need to be straight and accurate. The measurements need to be correct as well, and we'll talk about measurements in 1 second. For part B, the other blueprint will be an elevation view, and the view shows what the skyscraper looks like from the outside. So if I were looking at the front of your building, what would I see in front of me? So you need to include doors, windows, and anything else visible from the front. So if you look at my blueprint on the bottom down here, this is the elevation plan. So you can see, basically if you're taking a picture of your house, that's what it looks like. What needs to be included, though, on the right-hand side, as you see here, and it doesn't matter right or left to me, is you need to include all of the dimensions, the height of the roof, the height of the windows, the height of the doors, the height of the overall. And again, if you go to these links and Google other elevation plans, you can find more detailed instructions on how to do that. But basically, you're just drawing straight lines from the point of the drawing all the way to the right and straight down, and then you include what the dimension is. So individually, after you've drawn your blueprints, you will then build your model skyscraper using the blueprint. Sorry, not individually. After you draw it, you're going to build your skyscraper. Well, while you're waiting to test your model skyscraper, you're working on your next math task. This is the part that's individual, not the building. This part is you have to take your skyscraper, the prototype that you built, and you have to scale it up to the dimensions of a skyscraper in Raleigh. And you're doing this in meters. Okay, so in meters. So right here you've got the PNC Plaza, you've got 2 Hanover Square, you've got Wells Fargo Capitol Center, 1 Progress Plaza, and 2 Progress Plaza. So these are 5 skyscrapers that are actually in Raleigh. So you have to convert the height of your skyscraper to the height of these and tell me how many times bigger those skyscrapers are to yours. So that's done individually because we'll probably maybe have time in class to do this, but I'm not sure. So going back up here, when you've got your blueprint, it sounds like, that's easy, really easy. Well, when I give you a piece of graph paper, it's not going to be so easy because you can't just, if your skyscraper is 12 to 24 inches tall, obviously our paper isn't 24 inches tall. So you're going to have to scale your drawing down to a scale. I think we said the scale is 1 block on the graph paper is equal to 2 centimeters in real life. Okay, so 1 block is equal to 2 centimeters in real life. So what that means is if your drawing is 12 inches tall, if your building is 12 inches tall, you're first going to have to convert that into centimeters, and then from there you can start, convert your centimeters, scale it down to 1 block is 2 centimeters. So you're going to make a lot of ratios and proportions to get your drawing going. Okay, so I recommend, since there's probably 3 or 4 of you in your group, one of you working on the ground floor plan, one of you working on your elevation plan, and the third or fourth person helping each other out on the math calculations. You must be neat, you must be accurate, you must work together. So what your rubric looks like is here. So the top 3 parts are group grade, the bottom 2 are individual. So the first thing is your scale model blueprint ground floor plan accuracy. So for 3 points, your ground floor plan is drawn to the scale of 1 block to 2 centimeters, and calculations are accurate with no more than 3 errors. That means your doors, the walls, the windows, everything is to the right scale of 1 block to 2 centimeters. That's your first proportion, your first ratio. For level 3 on your blueprint of the elevation, same thing. Your elevation plan is drawn to a scale of 1 block to 2 centimeters. Your scale model blueprints overall, they're neat, well designed, and attractive on the graph paper. They're not sloppy. There's not eraser, tons of eraser marks and holes in your paper. Your common blueprint symbols are used throughout. So when you're drawing a blueprint, you're going to need to have a key somewhere so I know what each thing is representing. So if you put a circle that's representing a table, you need to tell me that's what it means. A ruler is used at all times to make the blueprint readable. Okay, so you must use rulers. And then the individual part of the rubric is here. So working with others is an individual grade. Your student was an engaged partner. You listen to suggestions of others and working cooperatively throughout the math project. So this is speaking about the math portion, okay? Just the math portion. And then this is the individual part too. Individually, did you scale your model to the skyscraper ratio? So calculations of height have been accurately scaled up to the size of a real-life skyscraper in meters with no error. So make sure you're reading all of the details of your rubric. It tells you exactly what has to happen in this project. And then after that, you've got your grade. So you'll get your total group points out of 9 points possible. Total individual points is 6 points possible, and then your total points overall for the project. There's 15 points possible for the math portion. I will then change that into a percentage, or you can change it to a percentage, and that'll be a minor grade in your math class. Okay, so again, you're going back. You are creating 2 blueprints, an elevation view and a ground floor view. You are including dimensions that are scaled down. So you can't do any line drawing until you have already scaled everything down. Use your scratch work that you did yesterday with your sketch. If you've got 12 inches written down, convert that into centimeters and then convert that into blocks, because 1 block on graph paper equals 2 centimeters for this project. So you're going to have to cross the systems with a little bit of math work there. So work as a team. If you have any problems, come see me or ask your STEAM teacher.